Hi everyone, welcome back to our channel. Today we are going to solve the power and power factor as well as the phasor diagram for our series RC circuit. So this is a very important derivation which will help us to calculate the power in a series RC circuit. Okay, let us go further. So already we know that the instantaneous power is given by the formula instantaneous voltage multiplied with instantaneous current. The instantaneous voltage is given by the formula maximum voltage into sine of omega t, and current is given by maximum current into sine of, so since we are writing for capacitor we are going to get omega t plus phi. So when you see this expression, I'm taking the voltage as well as current separately. Then I'm going to get sine omega t is the first term, and the another term is sine omega t plus phi. So to establish a relationship between this, we have a basic formula from trigonometric. 2 sine a sin b is equal to cos of a minus b minus cos of a plus b. But I need only sin a, sin b. Therefore, I can write down the formula of sin a, sin b is equal to 1 by 2 into cos a minus b minus cos a plus b. So this formula I'm going to use in this technique. So from here I'm going to get Vm into Im by 2 into, so this I can write down it as cos a minus b. A is omega t minus omega t plus 5. Okay, minus cos a minus b omega t plus omega t plus 5. Okay, so when you are doing this 1 by 2 I can write down it as Vm by root 2, and this also I can write down it as Im by root 2. So omega t will get cancelled, plus into minus is cos of minus 5, cos of minus 5 is plus 5, so minus cos 2 omega t. So cos of 2 times the frequency, which is nothing but cos of 360 degrees, will automatically will make this total term as 0, or 2 times the angular frequency term will become as 0. Automatically this is 0. Therefore the total active power, capital letter P, is equal to total voltage into total current into cos phi. You may get doubt why I have written capital letter V as well as capital letter I. So capital letter V are nothing but the RMS quantity of the voltage. Capital letter I is the RMS quantity of current, and cos phi is the power factor offer. Okay. So when you draw the power triangle for this, then how we are going to define the power factor? Okay, so the power factor I'm going to define, this is a factor of power. So in order to draw it, so we have the resultant formula for S is equal to P minus JQ. So just if I try to understand, P minus Q, so this is plus Q, and J I can write it as minus 90. So like this we want to draw the diagram. Okay, just try to take the horizontal component is P, and we are getting as minus 90. So how will get minus 90? When you travel only in clockwise direction, you are going to get minus 90. This is nothing but minus jq. So if you add it vectorially, then you are going to get s. Therefore, that's the formula of s is equal to p minus jq. So q at an angle of the imaginary part is minus 90. Therefore, you are going to get this value. Okay. So and now we need to find out the total phi. Okay, so how to write down cos phi? Cos phi I can write down as shown below. So what is cos phi? So this is opposite side, this is adjacent side. Adjacent side is p divided by s. Okay, so p I can write down it as v I cos phi divided by s. I can write down it as v into I. So vi will get cancelled, and cos phi I'm going to call it as factor, and p v into I am going to call it as power. So ultimately, if power V into I is multiplied with a factor of cos phi will lead to a power which is called as the active power. That's why it is called power factor. And this power factor may range from 0 to 1. This is all about the importance of power factor. Now let us try to draw the phasor diagrams for instantaneous voltage and current in a series RC circuit. Okay. So these are the waveforms or the waveforms of how to draw instantaneous voltage and instantaneous current across an RC circuit. The instantaneous voltage is given by the formula Vm sine omega t, and instantaneous current is given by the formula Im sine omega t plus phi. So this phi is nothing but this indicates positive angle. Okay, so positive angle means at t equal to 0 instant, at the time t equal to 0 instant, I of t should have a positive magnitude. I mean, you can see the magnitude of I of t should have an positive magnitude, then you are going to get plus 5. So how to draw this waveform is very very important. Okay, in order to draw this diagram, let's try to, so you can see here what is the omega t. Omega t is nothing but angular velocity. The units of omega is nothing but radian by second multiplied once again with second. Second get cancelled. The units of omega t is radian, or it may be in terms of degree. Okay, and the y-axis we are going to get instantaneous voltage, which is nothing but Vm. So it is sine 0, sine 90, sine 180, and once again it comes to 1 270 and 0. Okay, so this is the instantaneous voltage V of t, sine 0, and this is sine 90 degrees, this is sine 180 degrees, and this is sine 270 degrees, and this is sine 360 degrees. So this is the peak value of Vm. So this is Vm, and this we are going to get minus Vm. So where this value is minus 1, where this value is 1. So you can see here sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is, you are going to get it as again as 0. Now I want to draw the I of t. Okay, so I'm changing the color of the pen where you can understand better. So you can see here, so at t equal to 0, this is the instant at t equal to 0, I need to get the IMS positive. So here this is 90. Okay, so the waveform will start somewhere else from minus, and it comes to 0, and it comes to at 90, and once again the waveform goes down and it comes up to 270, and once again it travels up like this. So this is the waveform of current I of t. You can see here. So this is already started with an angle of phi. So since it is already started, I can say what is the first starting component and second starting component with respect to the reference phasor, which is nothing but the reference phasor of s theta with respect to clockwise direction. So I has started one. So one has is the first and voltage is the next. I can say current leads voltage lag by an angle of phi at t equal to 0. So this is how to understand at t equal to 0 the magnitude of current Im is positive, then I can say that current leads the voltage by 90 degrees. This is how to draw the phasor diagram. Hope you are able to understand. So if you feel my explanation is good, please like the video and share the video to your friends, those who are studying the same subject. So please give a good like for my explanation if you feel it is good, and share with your friends those who are studying the same subjects. And if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulasiram. Kindly support this channel because this is a free channel for the development of students and faculty. Thank you for listening patiently. You are strong. So just go through the derivation. Just P equal to VI cos phi, and apparent power S is equal to P minus JQ is very power factor, and just draw the waveforms of voltage current, and that's how we can understand current leads the voltage by an angle of 90. Thank you for watching. We'll meet in the another video.